Okay, so in this video, I'm going to give you a crash course on what you need to know whenever you work with simple harmonic motion, because there will be problems asking you to find displacement, to find velocity, or to find acceleration of a spring, okay? And this video will teach you how. Okay, so whenever you have a problem asking for displacement, you will want to find the A amplitude times cosine omega t. This W is a Greek symbol that stands for omega. And what omega is omega is the angular frequency. A is amplitude. And t is time in seconds. Okay? Now, when you find velocity, it's going to be the same thing as displacement, but all you need to do is remember this equation, okay? Because once you know the displacement, you could find velocity and acceleration, because velocity is just the displacement, but you derive it in terms of t. So velocity is going to be, derive this in terms of t. Derivative of cosine is negative sine, so you have negative a sine omega t, and then derive this inner in terms of t, you get w, which means velocity is equal to negative a w or omega sine omega t. Okay, and now you know what these stands for, okay? Now, to find out acceleration, you're going to derive this in terms of t, which means it's going to be the second derivative of the displacement in terms of t. So acceleration is equal to, deriving this in terms of t, derivative of sine is cosine, which means derivative of negative sine is negative cosine. So you have a negative a w or omega cosine omega t times omega again, because you derived inside now. Derivative of omega t is omega, which means acceleration is equal to a negative amplitude omega squared cosine omega t, okay? So this is to find acceleration. This is what you use to find velocity. And this is what you use to find displacement. And now let me repeat. Remember the displacement, okay? Because once you have the displacement, the velocity is just the first derivative of the displacement in terms of t. And acceleration is the second derivative of displacement in terms of t. All right?